In the couple of videos before, we learnt about different types of modes of transfer of heat, correct? Especially in conduction, we have a solid and the solid is going to transfer the heat. And when we understand it's a solid, now guys, material plays a very important part, correct? Like see, when I say solid, it can be any metal or it can be any sort of thing, isn't it? Now remember, not every solid is a good conductor of heat. Like I can't say that plastic or wood or any of these things are good conductors of heat. Whereas generally metals like silver, copper, iron, these are good conductors of heat, isn't it? Now, what determines whether the conductor or whether that material is a good conductor of heat? Now, this is a very important concept called as thermal conductivity of materials. Alright. Now, if we have to understand what is thermal conductivity, in layman terms, it's the characteristic or you can say the ability of the substance to conduct the heat. How good or how bad it is to figure it out. That's all. Okay. Now, to understand this one, let's do a simple experiment. Okay. Now, assume that you have a metal rod here, some steel or whatever, some rod is there. At one end, I'm going to start heating. Okay. Now, here, because of the conduction, the heat is going to transfer, correct? So, let's do the experiment here. Say at one end, you start heating. That end, it's going to start heating up, isn't it? Then what's going to happen? The heat is going to transfer and then again the heat is going to transfer. So like this, what is happening? Region by region by region, slowly the metal, whatever you have that specimen is going to start heating up, correct? Now what you have to understand is, as the body is heating up, it's also losing the energy to the environment, isn't it? It's not that it's going to keep the heat to itself. It's losing that heat energy to the environment. So here what's happening? It's heating up, it's losing energy, and also there is a change in the temperature, correct? Now this state of the specimen is called as the variable state. So in variable state, what's happening? The temperature is increasing, and also there is a small exchange of heat between the specimen and the surrounding. Fair enough? This state is called as the variable state. Now, after a point of time, okay, let's say you are going to constantly keep on supplying the heat. It heats up. Then the entire, that metal rod, whatever you have, that would have reached a stage where there is no change of heat within the specimen. The change of heat would have been constant by now. So this state is called as the steady state for the specimen. Now in variable state, temperature keeps on changing. But in steady state, the temperature becomes constant. Now, please understand, when we say the temperature remains constant, okay, when it reaches the steady state, the temperature is not the same throughout the metal rod. In the sense, the place where I'm supplying the heat will obviously be more in temperature compared to the far end. The near end and the far end, if you consider, that there will be temperature difference. But there is no more exchange of heat within the specimen. That's why we say that it has reached a steady state. Okay. Now, since it has reached the steady state, now don't you think the steady state or occurring to the steady state is completely material property? It depends on the material. Now, what defines this one? That is what we call as the thermal conductivity. Okay. Now, to understand this one, what we can do is, you can just take in terms of how much of energy you are giving, okay, and what is the area of cross section, what is the temperature gradient. Temperature gradient in the sense, the difference in the temperature in the constant state. Like the near end will have a different temperature, the far end is going to have a different temperature. The temperature difference is what we call as the temperature gradient. Okay, now generally temperature gradient is not a discrete value, it's more of a continuous value. Like it gradually changes, correct? That's what we call as the temperature gradient. Mathematically, the coefficient of thermal conductivity is given by K is equal to delta Q by delta T divided by A into delta T divided by delta X. Okay, so how do we define this? We can say that whatever the heat energy we are providing per unit area per temperature gradient, or you can say per unit temperature gradient. Okay, this is what we call as coefficient of thermal conductivity. Alright, the SI unit becomes watt per meter per Kelvin. This becomes the SI unit. Clear? Now, more the temperature coefficient, temperature in the sense the thermal coefficient, whatever we have, thermal conductivity, more the value, better the conductivity, or that is the heat conductivity. Lesser the value, lesser is the conductivity. That's why silver has very good thermal conductivity, somewhere close to 410. Okay. Wood, on the other hand, it's an insulator, right? Wood has a very low value, like 0.12 or something like this. Okay, gases, they have the least thermal conductivity. Okay, like hydrogen has 0.024. So, which is a very, very bad conductor. That's why what we do is, you know, this thermos flask? Thermos flask has air in between. Okay, the reason why we have air in between, because air is an insulator. So that basically holds the temperature. Okay, so it doesn't let the temperature go out, or it doesn't let the temperature come in. That's why it acts like an insulating layer. That's why we use gases. Clear? So the thermal conductivity is for the material, and that tells us how good or how bad the conductor is.